Hello, everyone. In the next few minutes, I'm going to tell you about our study that will be published in Developmental Science and as a result of joint work with Dr. Arnon from the Hebrew University. Here, we examine the developmental trajectory of children's auditory and visual statistical learning abilities, and we found modality-based differences in the effect of age on performance. In short, we found that while visual statistical learning improved with age, auditory statistical learning didn't. So one of the biggest questions in the study of human cognition is how do children discover the structure of their language? And more generally, how do children learn repeating patterns and regularities from their environment? So one answer that has been proposed is that children use statistical learning, the ability to implicitly detect patterns in the environment through distributional and statistical properties of the input. And indeed, research over the past 20 years has shown that statistical learning is present from very early in life. In fact, it's present already in newborns, and it's found across modalities. So we learn auditory regularities like those found in language, but also visual patterns and tactile patterns. However, there are still many open questions about the nature of statistical learning, and here we're going to focus on two of them. The first question has to do with the developmental trajectory of statistical learning. Is statistical learning stable across development, or does it change with age? And surprisingly, there's actually very little data about this. So even though statistical learning has been studied extensively with infants and with adults, only a handful of studies has looked at statistical learning between infancy and adulthood, that is, in children. And interestingly, these studies that did look at children showed a mixed pattern of results. So while some found that statistical learning improves across development, others found no change with age. Another question pertains to how domain-general statistical learning is. Is statistical learning an amodal mechanism, or are learning outcomes different across modalities? Previous studies show that there are modality-based differences in statistical learning for both infants and adults. However, no study has compared auditory and visual statistical learning in children, and importantly, no study has examined the development of statistical learning across childhood in both modalities using comparable tasks. So to address these questions, we've conducted the first large-scale study of statistical learning across domains and across development. We tested 230 children between the ages of 5 to 12 on visual and auditory tasks that were matched under statistical properties. So half of the children learned auditory patterns using a task modeled on the classic study by Safran et al. 1996. They listened for 2 minutes to an auditory stream which contained 5 trisyllabic words that had no breaks between them to indicate word boundaries. Then we asked the children to distinguish between real words and non-words that they've never seen before to see what they've learned. The other half of the children learned visual patterns, using a task similar to that used by Archiuli and Simpson. They saw a visual stream that contained 5 triplets of alien figures that flashed on the screen one by one. As in the auditory task, they then had to distinguish between real triplets and foil triplets to see what they've learned. And when we compared children's accuracy on both tasks, we found a difference in the developmental trajectory of statistical learning across modalities. While learning improved with age in the visual domain, learning did not change much during childhood in the auditory domain. That is, between the ages of 6 to 12, we found that performance remained the same in the auditory domain, but not in the visual one. These novel results have several implications. First, our main finding is that statistical learning develops differently across modalities. Visual statistical learning improves over time, while auditory statistical learning doesn't. And this modality-based difference helps to reconcile the mixed pattern of results found in previous studies, which report improvement in visual statistical learning tasks, but no difference between children and adults on auditory statistical learning tasks. Now, when taking modality into account, these results are no longer contradictory. Second, we found that auditory statistical learning did not improve with age. This actually supports its postulated role in language acquisition, which is also at its prime during infancy. If statistical learning plays an important role in language acquisition, it should be age invariant, which is exactly what we find here. And finally, our findings suggest that statistical learning is not a unitary and stable capacity. Rather, it develops with age, and it develops differently across modalities. This supports modality-sensitive accounts of statistical learning and helps shed light on the nature of these abilities. So that's it. Thank you very much for listening. I hope you've enjoyed this teaser, and I hope you'll enjoy reading the full paper.